What were the deadliest lockout-tagout failures in history? Imagine working on a machine, thinking it's safe because you turned it off, only to find out it suddenly starts up again. That's the danger of lockout-tagout failures. These failures happen when energy sources are not properly isolated before maintenance. They can involve electrical, mechanical, hydraulic, or pneumatic energy. If the energy isn't fully controlled, it can cause serious injuries or even death. Many accidents happen when workers don't apply locks or tags on energy-isolating devices or forget to verify that the machine is completely de-energized. For example, a worker might shut off a machine at the switch but forget to lock out the circuit breaker. If someone else re-energizes the system, the worker could be electrocuted or crushed. These incidents often involve moving parts, hydraulic doors, or rotating machinery. When energy is released unexpectedly, it can cause crushing injuries, amputations, or falls from elevated work areas. Between 2011 and 2021, at least 9 workers died due to lockout-tagout failures. These fatalities show how dangerous improper procedures can be. One notable case involved a technician who turned off a machine at the wall switch but failed to apply energy-isolating devices and locks. While working, the machine unexpectedly energized, causing fatal injuries. This case highlights the importance of not just turning off a machine but fully isolating all energy sources. Another tragic example happened at a food processing plant. A worker was fatally injured when a jammed conveyor belt reactivated because lockout procedures were ignored. The emergency stop failed, and the worker was pulled into the machine. In another case, a millwright was repairing a log debarking machine. He didn't verify that the machine was fully de-energized, and it released uncontrolled energy, leading to his death. Electrical safety standards requiring that all energy sources be identified and physically isolated with lockout devices. These devices prevent Lockout-Tagout until they are removed. Before starting work, workers must verify that the machine is completely de-energized, including testing circuits for voltage. Stored energy, like capacitors or hydraulic pressure, must also be released or blocked. Equipment design can help reduce risks by making lockout points easier to access and more fail-safe. Effective lockout-tagout programs include detailed procedures, employee training, and regular audits. Electrical engineers should work with maintenance teams to design machines with clear energy isolation points and labels. Supervisors must enforce strict adherence to lockout steps: shutting down, isolating, locking, tagging, releasing stored energy, and verifying de-energization. Emergency stop systems are useful but should never replace proper lockout procedures. They are a backup, not a substitute. The key lesson from these failures is that turning off a machine is not enough. Physical locks and tags are essential to prevent accidental Lockout-Tagout. Skipping steps or rushing through procedures can lead to preventable deaths. Training must emphasize the hazards of residual energy and the importance of following all steps carefully. Regular reviews of lockout procedures, especially after incidents, can help prevent future tragedies. In the end, these deadly failures show us how vital it is to control all energy sources before working on machinery. Proper lockout-tagout practices save lives by making sure machines stay off and safe to work on. Electrical safety and standards are there to guide us, but only strict compliance and thorough procedures can truly protect workers from harm.